These are the odd solutions for the PERT review packet. All right, number 1 is 5 times the quantity 2 minus a minus 4. We need to distribute the 5 first, which gives you 10 minus 5a minus 4. Then you're going to combine like terms. 10 minus 4 is 6. You can't do anything with 6 minus 5a because it's not like terms. All right, same situation here, except for we're just going to distribute a negative. So I've got negative x minus 3 plus 6x. Combine like terms. Negative x plus 6x is 5x minus 3. Those are not like terms, so you can't do anything else. Number 5, same situation. Distribute the 2. So you have 1 plus 16 plus 4x. 1 and 16 are like terms, so you get 17 plus 4x. All right, with number 7, we're talking about absolute values. In order to solve an absolute value, you have to isolate the absolute value. So I need to multiply both sides by 10 to get rid of this 10 in the denominator because it's not included in my absolute value. And you end up with the absolute value of 3 minus 2n equals 10. You cannot start solving inside the absolute value. You actually need to set it equal to two different answers. So you have 3 minus 2n equals negative 10, and 3 minus 2n equals 10. Anytime you're solving for an absolute value, you need to split it up into two problems with a positive and negative version of the solution. So now you're just going to solve for n. So you subtract 3 from both sides. You get negative 2n is equal to negative 13. Divide both sides by negative 2, and you get n is equal to 13 over 2. It's positive because it was a negative over a negative. And then over here, you're going to do the same. Subtract 3 from both sides. You get negative 2n is equal to 7. Divide both sides by negative 2. So n is equal to negative 7 halves. So your solution set is negative 7 halves and 13 halves. Okay, same situation here. We have an absolute value, but before we can solve the absolute value, we need to isolate it. So you're going to add 4 to both sides, leaving you the absolute value of 10n plus 7 is equal to 87. Now in order to solve this, you have to split it up to 10n plus 7 equals negative 87, and 10n plus 7 equals positive 87. That's the only way you can solve an absolute value like this. So now you're going to solve for n by subtracting 7 from both sides, leaving you 10n is equal to negative 94. Divide both sides by 10. You get n is equal to, when you reduce, you get negative 47 over 5. And then over here, I'm going to subtract 7 from both sides, giving me 10n is equal to 80. Divide 10 by both sides, you get n is equal to 8. So my solution set here is negative 47 over 5 and 8. Okay, number 11, same situation. We've got an absolute value. In order to isolate the absolute value, I need to multiply both sides by 8. These 8's cancel, which is the whole purpose of doing that. So we have the absolute value of 6 minus 2x is equal to 16. So you need to split it up. 6 minus 2x is equal to negative 16, and 6 minus 2x is equal to positive 16. Now solve for x by subtracting 6 from both sides, giving you negative 2x is equal to negative 22. Then divide both sides by negative 2, giving you x is positive 11, because a negative over a negative is a positive. Subtract 6 from both sides on the other equation. You get negative 2x is equal to 10. Divide both sides by negative 2, and you get x is equal to negative 5, because a positive divided by a negative is a positive. So your solution set is negative 5 and 11. All right, in 13 we're dealing with inequalities. We treat an inequality just like we would treat an equal sign with just a couple different rules. If you end up dividing or multiplying by a negative number, then you have to flip the sign, but otherwise we treat it pretty much the same way. So on this side we actually have some like terms. Negative a plus 3a is actually 2a divided by, is less than negative 12. We need to isolate the a, so we divide both sides by 2. And you're left with a is less than negative 6, which we need to graph on the number line. So if I have negative 6, negative 7, and negative 8. Remember, a less than or greater than is a parenthesis, and a less than or equal to or greater than or equal to are brackets. So in this case, we're dealing with just a regular less than. So we're going to use a parenthesis. The parenthesis always opens in the direction that your arrow is going to go. And because we're talking about less than, we're going to shade this way. All right, 15, same situation. Combine your like terms first. 5n minus 3n is 2n is less than or equal to 4. Divide both sides by 2. You get n is less than or equal to 2. So again, I'm going to draw a number line. 2, 1, 0. It's going to be a bracket because it's less than or equal to. Remember, the bracket is the same as the closed dot that you used to use. And then I'm going to shade this way because it's less than. All right, 17 is a system of equations. You can use multiple different ways to solve this. You can use graphing, you can use elimination, or you can use substitution. In this case, I think I'm going to use elimination. So let's go ahead and eliminate our x's. So in order to eliminate our x's, I need a positive and negative version of the same number. So I've got 18 here and 9 here. In order to make 9 the opposite of 18, I need to multiply by negative 2. Because that will give me negative 18, and negative 18 cancels out positive 18. So you distribute the negative 2 to every piece of the first equation. So you have negative 18x minus 2y is equal to positive 2. And then you write the second equation underneath it. Now you treat it like an addition problem. Negative 18x plus 18x is 0, so that cancels. Negative 2y plus 7y is 5y. And 2 minus 7 is negative 5. So now I'm able to go ahead and solve for y. You get y is equal to negative 1. And then you take this negative 1 and you plug it into one of your equations. I'm going to choose the top one. So I have 9x plus y is negative 1 is equal to negative 1. So this says 9x minus 1 is equal to negative 1. So I'm going to add 1 to both sides. I get 9x is equal to 0. Then I'm going to divide 9 from both sides. You get x is equal to 0. So your ordered pair is 0, negative 1. And that's your solution to the system. All right, we have another system for number 19. Looks like the best option here will also be elimination. So in order to make it's going to be easier to make negative 5 the opposite of negative 15 than try to make negative 7 and negative 9 cancel. So in order to make negative 5 the opposite of negative 15, I need to multiply it by negative 3, so I get positive 15x. So I have negative 15x minus 9y equals 24. The first equation doesn't change. And then you distribute the negative 3 to the entire second equation. So you get positive 15x plus 21y is equal to negative 36. Treat it like an addition problem. Your x's cancel. Negative 9 plus 21 is 12. Y is equal to negative 12 because 24 minus 36 is negative 12. Divide both sides by 12. You get y equals negative 1. And then again, you're going to plug that back into one of the equations. Doesn't matter which one. I'm going to choose the bottom one just because it has smaller numbers to deal with. So I have negative 5x minus 7 times negative 1, because we know y is negative 1, equals 12. So you have negative 5x, negative 7 times negative 1 is positive 7, equals 12. Subtract 7 from both sides. You get negative 5x is equal to 5. Divide both sides by negative 5, and you get x is negative 1. So your ordered pair is negative 1, negative 1. All right, 21, we have another system. So it looks like elimination is actually going to be the best option here as well. I'm going to go for the y's this time because it's going to be easier to make y the opposite of 5 than 3 the opposite of 5. So in order to make y the opposite of 5y, I need to multiply everything by negative 5. So my top equation becomes negative 15x minus 5y equals positive 35. And then leave your second equation the same. Treat it like an addition problem. Your y's are going to cancel. Negative 15x plus 5x is negative 10x, and 35 minus 5 is 30. Divide both sides by negative 10, and you get x is equal to negative 3. Plug back into one of the equations. I'm going to use the top one because it has smaller numbers. So 3 times negative 3 plus y equals negative 7. 3 times negative 3 is negative 9. Plus y equals negative 7. Add 9 to both sides, and you get, y is equal to 2. So your ordered pair is negative 3, 2. All right, 23 says 7m squared minus 9 equals negative 10m. So you can do this a couple different ways. First off, you're going to have to move the 10m over to the other side in order to be able to factor this, because in order to factor, everything has to be set equal to 0. So you've got 7m squared plus 10m minus 9 equals 0. So first I'm going to try to just do regular factoring. 7 times 9 is 63, and we need to find factors of 63 that give us 10. So I've got 1 in 63, 3 in 21, and 7 and 9. None of those are going to give us 10, so we're going to have to use the quadratic formula. So A is 7, B is 10, and C is negative 9. The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and plug in. Negative b is negative 10 plus or minus the square root of 10 squared minus 4 times 7 times negative 9 all over 2 times 7. X equals negative 10 plus or minus the square root. 10 squared is 100. Negative 4 times 7 is negative 28 times negative 9 is 252. All over 14. $100 plus 252 is 352. All over 14. Okay, we're going to have to simplify the square root of 352. So 352 is 16 times 22. 16 is 4 times 4. 22 is 11 times 2. You have a repeat of 4's here, so you can bring a 4 out front, leaving behind the square root of 22 because 2 times 11 is 22. So I'm going to change this from the square root of 352 to 4 square root of 22. Now remember, if you draw a heart around these, you're going to look and see what each one of them is divisible by. So we've got 4, 10, and 14. The only number that all of them is divisible by is 2. So you're going to factor out a 2. Which is going to leave you negative 5 plus or minus 2 square root of 22 over 14. And the benefit of that is now the 2 and the 14 can reduce to 1 and 7. So your answer is negative 5 plus or minus 2 square root of 22 over 7. All right, same situation here. Obviously, because of this squared, we're going to have to factor. So I'm going to move everything over to one side. So I'm set equal to 0, so I can factor. Okay, one more step. So you have 6n squared plus 11n minus 12 equals 0. Okay, let's see if we can go ahead and regularly factor this. 6 times 12 is 48. Factors of 48, they could give us 11. Let's see, 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. No, 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 no. Okay, none of those are going to work, so we're going to have to use the quadratic formula again. So we've got A is 6, B is 11, and C is negative 12. Alright, there's our quadratic formula. Now we're just going to plug into it. So we have x equals negative 11 plus or minus the square root of 11 squared minus 4 times 6 times negative 12 all over 2 times 6. Clean this up a little bit. The square root of 11 is 121. Negative 4 times 6 is negative 24. Times negative 12 is positive 288. All over 12. Okay, clean it up a little bit more. 121 plus 288 is 409 over 12. I'm trying to see if anything, I don't think 409 can be reduced at all, so that's actually our answer. Okay, 27. Same situation. Move everything to one side so we can set it equal to 0 because obviously we're going to have to factor. So 3r squared plus 4r minus 18 equals 0. Okay, 18 times 3 is 54. Let's see if any factors of 54 are going to give us 4. So we have 1 and 54, 2 and 27, 3 and 18, and 6 and 9. No luck. Quadratic formula it is. A is 3, B is 4, and C is negative 18. So let's go ahead and plug in. X equals negative B, which is negative 4, plus or minus the square root of B squared minus 4AC all over 2A. Clean it up. 4 squared is 16. Negative 4 times 3 is negative 12. Negative 12 times negative 18 is positive 216. All over 6. 16 and 216 is 232 all over 6. So let's see if 232 can be reduced. 232 is 58 times 4. 4 is 2 times 2. 58 is 29 and 2. So I can bring a 2 out front. And I'm left with a 58 on the inside because we can't do anything with 29. So you have x equals negative 4 plus or minus 2 square root of 58 all over 6. Draw your heart and see if all of them are divisible by something. They're all divisible by 2. So if I factor out a 2, I'm left with negative 2 plus or minus the square root of 58 all over 6. 2 and 6 can be reduced to 1 and 3. So your answer is negative 2 plus or minus the square root of 58 over 3. All right, 29. We have 4 terms. A dead giveaway for having to factor by grouping is 4 terms. So I'm going to group my first 2, and then I'm going to group my second 2. Remember, you want to include, if your third term is negative, you want to include the negative in the parentheses. And that's always going to tell you, if your third term is negative, that you're going to have to factor a negative out of the second group. So what can I factor out of the first group here? What do they have in common? They have 3x squared in common. And that leaves me with 7x plus 6. And then in the second group, I know I'm going to factor out a negative, but what do they have in common? Looks like a 7. So I'm left with, if I factor out a negative 7, I'm left with 7x plus 6. Now the whole goal of factoring by grouping is that these end up being the same. So if they don't, then maybe you need to realize that you need to factor out a negative. And then what you're going to do is you're going to write these together. So you have 3x squared minus 7. And then you write what this is. 7x plus 6. And that is your solution. All right, 31 also has 4 terms, so I'm going to go ahead and group it. Notice this one does not have a negative for our third term, so you don't need to group that plus in. What can we factor out of our first house here? So what do they have in common? Looks like 7v squared. So if I factor out a 7v squared, I'm left with 8v minus 7 plus, what do they have in common? Looks like just a 5. If I factor out a 5, I'm left with 8v minus 7. So obviously I'm doing something right because these are the same. So I have, now you're going to put these two together, 7v squared plus 5. And then you're going to write this one, 8v minus 7. And that is factored, so you're good. All right, 33. They give you the function g of x, and they want you to try g of 6. So for g of 6, all I do is everywhere there's an x, I plug in a 6. You too. All right, so g of 6 is negative 2 times 6 is negative 12 minus 3. So g of 6 is negative 15. All right, 35 has the function k of x is equal to x minus 4, and they want to know what k of 6 is. So all I'm going to do is write k of 6 here. Everywhere there's an x, I'm going to put a 6. So you have k of 6 is equal to 2. Here they give you the function h of x is equal to x cubed plus 5x, and they want to know what h of x squared is. So everywhere there's an x, I'm going to put an x squared. Bless you. All right, so you have h of x squared equals, when you take a power to a power, you multiply your exponents. So you have x to the 6th plus 5x squared. And that is your solution. All right, here they give you the square root of 175n squared, and they want you to simplify it. So I always break it up into the square root of 175 times the square root of n squared. So 175 is 25 and 7, and 25 is 5 and 5. So you can bring a 5 out front and leave a 7 inside. And here, this is n times n, so you can bring an n outside. So you have 5n times the square root of 7. Right here we have the square root of 192 times n. So again, I'm going to break it up. Square root of 192 times the square root of n. And 192 is 96 and 2. 96 is 48 and 2. 48 is 6 and 8. 6 is 3 and 2. 8 is 4 and 2. And 4 is 2 and 2. So now we're looking for sets of 2 to take out front. So I have 1 here, 1 here, and 1 here. So 2 times 2 is 4, times 2 is 8. And then I'm left with, all that there's left is a 3. So it's square root of 3. Times, I still have the square root of n, can't do anything with that. So my answer is 8 square roots of 3n. Okay, here we're dealing with radicals. So remember, when you're adding and subtracting radicals, your index and your radicand have to be the same. But before you can determine if they're the same, you have to put everything in simplest form. We're in simplest form here and here. However, here I can probably simplify some. So 45 is 5 times 9, and 9 is 3 times 3. So I can bring a 3 out front and leave the square root of 5. And remember, all of this is multiplied by 2 because of this 2 here. Technically, negative 2. So I have 3 square root of 3 minus 3 square root of 5 minus 2 times 3 square root of 5. So this is 3 square root of 3 minus 3 square root of 5. Negative 2 times 3 is negative 6 square root of 5. And now I can combine these two because our index is 2 and our radicand is 5. So you're going to leave 3 square root of 3 alone. Negative 3 minus 6 is negative 9. And then you just write your square root of 5. Okay, here you're going to distribute. Now, in order to be able to multiply radicals, just your index has to be the same. And then you'll multiply your radicals, or your radicands, I'm sorry. So square root of 15 times square root of 2, they both have an index of 2. So I can multiply them to get square root of 30. Plus, square root of 15 times square root of 5 is square root of 75. Now I can't add these together yet because they don't have the same radicands, but let's simplify and see if there's anything I can do. 30 is 10 times 3, and 10 is 5 times 2. So 30 is actually in its simplest form. Let's see about 75. 75 is 25 times 3, and 25 is 5 times 5. So I can actually bring a 5 out front and just leave the square root of 3. So our answer is the square root of 30 plus 5 square root of 3. Can't take it any further because our radicands are different. Same thing here. I'm going to go ahead and distribute negative 2 square root of 5. So when you do negative 2 square root of 5 times 3, you just multiply negative 2 times 3, and that gives you negative 6, and then you have the square root of 5 still. And then when you multiply negative 2 square root of 5 and 2 square root of 5, you multiply negative 2 times 2, which gives you negative 4. And then you do square root of 5 times square root of 5, which is the square root of 25. So you have negative 6 square root of 5 minus 4, and we know the square root of 25 is 5. So it's actually negative 4 times 5. So we have negative 6 square root of 5 minus 20. Those are not like terms, so you cannot combine them, and so that is your answer. Okay, 49, we have 3 over 4 minus 3 square root of 5. You have a radical in the denominator, which is not allowed, so you're going to multiply by the conjugate. Remember, the conjugate is the same as the denominator. You just change the operation. So it was minus, now you write plus. Make sure you put parentheses around things so you don't get confused when you're multiplying. All right, so I have 3 times the quantity 4 plus 3 square root of 5. And then remember, when you're multiplying conjugates, all you have to do is multiply your first terms and your last terms. So 4 times 4 is 16 minus 3 square root of 5 times 3 square root of 5 is 9 square root of 25. So I'm going to distribute the 3. I get 12 plus 9 square root of 5 all over 16 minus 9 times 5, because the square root of 25 is just 5. So now I've got 12 plus 9 square root of 5 over 16 minus 45, which is 12 plus 9 square root of 5 over negative 29. And that is your answer. We're okay now because we have a radical in the numerator but none in the denominator, and that was the goal. All right. Now we're dealing with fraction exponents. So we've got 216 to the 5/3 power. So remember, we're going to take our denominator and we're going to make it our index. So you say the cube root of 216 to the 5th power. And remember, you can do this one of two ways. You can either take 216 to the 5th power and then take the cube root of it, or you can take the cube root of 216 and then take it to the 5th power. In this situation, I suggest that you take the cube root of 216 first. The cube root of 216 is 6. So you end up with 6 to the 5th power. And 6 to the 5th power is 7,776. All right, same situation here. Bring your denominator out to your index. So you have the cube root of 64 to the 4th power. Again, you can do it one of two ways. You can do cube root of 64 to the 4th power, or you can do the cube root of 64 to the 4th power. Either way, you're going to get the same answer. In this situation, I think this way is easier. Cube root of 64 is 4. So you end up with 4 to the 4th power. And 4 to the 4th power is 256. All right, same situation here. We're going to bring our index out to be our denominator out to be our index. So we have the square root of 25 cubed, which again could be the square root of 25 cubed, or the square root of 25 cubed. You get the same answer either way. In this situation, I also think this one is easier, because we know the square root of 25 is 5. So 5 cubed is 125. All right, so you know, just looking at the variables in the denominators, that this is going to be an LCD problem. So my LCD needs to have all the pieces. So I need an M, I need a 6M, but I already have an M, so I just need a 6. And then I need a 3M, but I already have an M, and I already have a 6, so 3 is okay because 3 goes into 6 perfectly. So my LCD is 6M. And that gets multiplied by every piece to see what cancels. Here your M's cancel, here your 6M's cancel, here your M's cancel, and 6 divided by 3 is 2. So now you're going to multiply what you've got left. I've got 6 times M plus 5 plus just a 1 equals 2 times 1 is 2. Distribute your 6, you get 6M plus 30 plus 1 is equal to 2. 6M plus 31 is equal to 2 because 30 plus 1 is 31. Subtract 31 from both sides. You get 6m is equal to negative 29. Divide both sides by 6, and you get m is equal to negative 29 over 6. All right, same situation here. We've got an LCD problem. So I need all of your denominators represented. So I need a 5x. I need an x, but I've already got it. I need an x, but I've already got it. So my LCD is 5x, which gets multiplied by every piece. Here, the 5x cancels. Here, just the x cancels. And here, just the x cancels. So now you multiply what's left. Here, it's just a 1. Here, it's 5 times x plus 2. Don't forget your parentheses. And here, it's 5 times 2, which is 10. Distribute the 5. Combine like terms. And now just solve for x. Divide both sides by 5, and you get x equals negative 19 over 5. And that's it.